Hello, hello. What a treat to be speaking at EMF and to a room full of people who are excited about birds. So, hello, my name is Hugh, and this is Rotundest Robin. So, my name is Hugh. I am a maker, so my partner and I actually made the 10 times scale Tildagon badge. So it's at Null Sector if you want to check that out. I'm a community organizer with some PyData folks. And my day job is as a developer advocate at Ivan, where I help look after our Apache Kafka community. Today, though, I'm going to be talking about a personal project that's more of a kind of a amateur ornithologist direction, as you can probably tell from the Bill Oddie drip. So, answering a dumb question with a smart bird feeder. And that question is this. Is this robin abnormally large? Look at them. I can't overstate how massive this robin is in person. We put a bird feeder up on the window in my office, and every time this robin lands, there's like a notable thwack, like someone's thrown a tennis ball at a window. And you know, I'm sat there like very kind of like ADHD whilst I'm supposed to be on calls, listening to this bird landing repeatedly. And my curiosity gets the better of me. Just like, how heavy is this robin? I'm an engineer, kind of, so I should be able to figure this out, right? So I decided to try and build a bird feeder that could collect the data I needed to answer my question. So how do you even go about doing something like this, right? There's a bunch of different ways that you can weigh things electronically. You might be familiar with like piezoelectric crystals, you know, you compress them and they produce a voltage. I ended up going for something way cheaper, at least for this weight range, which is anything between like 5 and a couple hundred grams, which is a load cell, which is a very precisely milled piece of aluminium with a hole through the middle with strain gauges arranged around it, which are basically resistors whose resistance changes when force is applied, and by taking a read of all of those measurements, you can calculate a weight. Now, those changes are really, really small, so to turn those changes in voltages into like an actual weight or mass you can do something with, you need an amplifier circuit. So in this case, an analog to digital converter, which takes those tiny voltages and outputs it as a 24-bit integer that you can read and do stuff with. To actually do that reading, I'm using super cheap Raspberry Pi 3. I think it's like agricultural. I bought a whole box of them bulk, and it came smelling strongly of plants. So like, any guesses on where that one came from? And my existing bird feeder has this like nice removable tray in it anyway, so it's super easy to bolt that load cell in between the two. I then calibrated my setup with some reference weights. So UK Songbirds, the lightest I believe is a gold crest, coming in at something like 9 grams. And then, you know, up into the world of determined pigeons and squirrels in the 100-gram range. So I calibrated my setup with these kind of known masses in that range and did some testing. You also have to factor in, of course, that when birds come to a bird feeder, they eat birdseed and they take it with them. So you need to tear after each bird visit to account for the mass that they've eaten. But with all that done, we have this nice little shell output, and we found out how heavy the robin is, right? Not yet. True, I spend a lot of my day watching this bird feeder, not enough to know what every single one of these visitors was. So I didn't know who I was weighing, right? So now was the time I thought to, you know, add a camera to my setup, and so I can get a sense of what bird visitors were getting. And at this point in the project, I also start like, you know, moving from that initial period of excitement as I build a stupid thing to actually doing some research and being like, okay, how much do robins actually weigh? Like, it would be useful to know. I'm looking at the RSPB website, which is a great resource, and I come across this miserable little tidbit. The average robin life expectancy is 1.1 years? But they're little guys, come on, they should outlive us all. And that kind of bummed me out, because I love robins, but also, I realized I'm on the clock. I've got to weigh this robin. Not just in less than a year. I've got like 6 months. It's like, you know, October by this point. You know, robin season is coming. So I've got to get on the clock. So I add my camera. And this is great. Like, Who doesn't love extremely low resolution pictures of birds? Am I right? And this was awesome because I have all these pictures of birds and I can look at them from my phone and that's very fun. But then this introduces another problem, which is I live in leafy southeast London and I was getting a lot of visitors, both robins and non-robins. Which pictures I use? There's a little mouse. We were big fans of the little mouse. He climbs the bricks at the outside of my flat like it's a ladder and comes and eats birdseed. He's everything to me. Very determined pigeons. Great tits, coal tits, robins, lots of visitors. And so many animals were visiting. I had 500 plus pictures a day, which after a week is a lot of pictures to go through and start labeling species manually. So I, being a kind of a data-inclined person, go, oh, this is like a machine learning problem, right? I'll make a classifier that will identify bird species, or I'll use one somebody else has already made. And then I don't have to label all the data manually, I thought. But I'm not a machine learning engineer, so I have to learn how to do that first, right? But that's part of the fun of a project like this. I thought. I spent a lot of time, there's an XKCD for everything, we know this, it's EMF. I spent a lot of time looking at TensorFlow, which is this, I think, open source framework out of Google originally for building machine learning stuff and classifiers. And I was using my existing data, manually labeling some of it to have training data, and then trying to train this model. And I quickly realized that I, didn't have enough data from one bird feeder with some very low resolution pictures to build a general purpose model that would recognize UK bird species. And I don't actually know how to fine tune a model. Funnily enough, that's quite complicated. If you're not aware, machine learning models of this kind of classifier variety have layers which take each section of an image and do some kind of maths to them, pass it on to the next layer, and then give you some kind of output. And if you know what you're doing, you can get really great results. If you don't, if, for example, you got an E at A-level maths, it's a lot of looking at graphs and being like, yeah, I don't know how that works, I don't know how that works, I don't know how that works. So I went back to the drawing board. I imagine many people in the audience here may be familiar with Merlin. If you're not, it's a great app. Take a picture of a bird, take a recording of a bird, and it'll tell you what it is. It's magic. Merlin is fantastically accurate. It still has some level of uncertainty. I think quite often it will predict 2 different tit species simultaneously, because there's a little bit of kind of overlap there in sound. But the way Merlin manages to be so accurate is it does have classifier models that are trained on pictures of birds and sounds of birds in the way that I was trying to train it, but it's specifically trained on regional bird species. So there's a model for the UK, there's a model for Western Europe, there's a model for Eastern Europe. And by reducing the number of bird species it's trying to predict from, it increases accuracy. Now, that's super cool. Hypothetically speaking, if one were to download the APK of Merlin and to download the model weights and the model implementation, you could run Merlin at home. I wouldn't do that. So I had to consider some other options. The data is there, though, for those willing to look. Instead, I found this model on GitHub. There will be a link to this at the end if you want to go check out the awesome team that made this. But this is a model that can predict species from a bunch of different UK bird species, conveniently for us, including robins. So having gone on a journey of I'm going to make this myself, and then very quickly being humbled, I went and found this implementation that someone else had made, and I decided to run that. But then I had another problem. I'm using Raspberry Pi 3, right? It is of slightly dubious origin, but it works. But as you may well be aware, Raspberry Pi 3 isn't necessarily machine learning hardware. It'll give it a good go. And in the process of trying to coax a Raspberry Pi 3 into running this model, I did manage to kill one. Wasn't great. He'd had a hard life before he came to me, but nonetheless, didn't feel awesome. So I needed to figure out a way of running my bird species predictor model without melting a hole in my desk. This would usually be the part of the talk if I were doing day job stuff, where I'd be like, well, what you need is Kafka and events and a microservices architecture, and we're going to distribute things horizontally, and it's enterprisey. But I'm off the clock, so I get to say that it's much easier to do it with Google Drive. Other cloud storage options are available. If you have your own NAS, you could use that. But just a single API call pushing the images from the Raspberry Pi over Wi-Fi to storage, which works great. And then it means you have a batch of images that you can download, and then you can use any slightly more robust hardware, like this laptop, for example, to do the actual classification, to run the model against all of the images, and to annotate them. And if you do that, you end up with some images like this, which was very exciting. It took me a long time to get to this point. But I ended up with thousands and thousands of images like this, where I have an image of a bird with the species, the time the image was taken, and the weight, all in the file name, so I don't have to deploy a secondary database because I'm lazy, despite being a data engineer. Great, so this is enough to weigh a robin, right? Like, picture of robin, weight of robin. Surprisingly, no. I'm looking at the data. And I am doing some Kafka stuff behind the scenes here because I couldn't help myself. But I'm streaming all the weight data out, and I'm using Grafana to plot it so I can kind of keep an eye on the bird feeder and pretend I'm doing work for my job. And I could see in the data that the scale would occasionally get stuck at 20 grams, and then it was getting stuck at like minus 50 grams. And then it was just going real wrong. Like, I was calibrating it, and then the numbers were just falling apart, right? So I'm plotting it, and I'm like, okay, I'll plot it against, like temperature that day, and humidity, and air pressure. Like, is there something interfering with my sensor? Wait a minute. Surely not. It was the pigeons. I went through and I lined up all of the pictures on the camera of pigeons, and all of the times where the data broke, and it was pigeons breaking my sensor. As you can see here from their trail of carnage that they reached through my data set, that pigeon does not weigh negative 96 grams. It probably weighs about 300 to 400 grams. The pigeons were staying so long, and they were eating so much birdseed that the setup would re-tear, it'd go back to 0, and the pigeon would keep eating, and it would repeat. And so the weights you're seeing here in the negative are not an error reading per se. They are how much birdseed that pigeon ate in one sitting. 86 grams. It's just insane. Now, I gave a much shorter version of this talk at PyData London, like a little lightning talk, and everyone there had lots of suggestions about how to deal with the pigeon menace, ranging from air horns, flashing lights, lasers. I've got a soft spot in my heart for pigeons. I feel like they're much maligned. They're actually, if you don't know, feral rather than wild for the most part. Like, they were previously domesticated by people, now less so. And even if they were kind of ruining my experiment, I mean, look at that one in the last frame. He's looking right down the camera. He knows what he's doing. I went for like a more robust attachment of the bird feeder to the wall. I used some bigger suction cups, and I set up my tearing so that it would be pigeon-proof, and I just kind of accepted that I would be constantly pouring birdseed into an insatiable pool of pigeons. Okay, but with all of that done to account for the pigeon problem, we've got a smart bird feeder. We've deployed our robin detecting classifier, deployed being generous, it's running on my laptop, and we've collected our data set. Just how heavy is our robin? Okay, we're very nearly there. But I couldn't quite at this point say, this robin weighs this amount, because I couldn't actually identify unique robins yet. I have lots of pictures of robins, but it could be lots of different robins, and maybe I'm getting inaccurate readings with different weights. Maybe I have lots of robins that weigh the same amount. Like, I need some way of pulling out unique robins. And this was the very last step. I need to look at all of my annotated image data and try and find individual birds, specifically robins. But I'm not a data scientist. I spoke to some friends who are data scientists, including some who you might hear laughing politely in the audience, about what I did in this next step. And they did that thing that friends do when you're like doing something that's a bit out of your comfort zone, and they're very encouraging. But they made some gentle suggestions about ways that you would actually do this that aren't mental. So I did a very silly thing. I took all of my pictures of robins, and I created embeddings of them, much the same way you would for facial recognition. And then I did similarity clustering on those embeddings, like in a vector database, to try and see if I could do like Robin Face ID. Any guesses for working out how that went? I was also using like k-means clustering, which turns out you can't use the first clustering method you hear of, go figure. But I got what looked like reasonable results. And I think this is something that like any level of anything that's like ML or AI adjacent, this is always a big trap where you're like, oh, these numbers look like good numbers, right? Like, you know, I've got robins, I've got weights, I've got times of the day, like this looks like real data. But then if you scratch under the surface, you're like, oh, this is junk, right? Like I'm finding correlation and where there isn't any, I'm lumping things together, I'm using this technique wrong. So having presented this solution to a bunch of very nice data scientists, they gently came over and went, hey, have you considered just using a histogram? Like, why aren't you just using a histogram? You'll be able to see individual birds and spikes in the weight and group them and correct for errors that way. And I was like, oh, yeah, that's why you guys are data scientists. And I'm a data engineer. But with that done, we have this very nice plot of bird weights. We have our frequency of that weight, and we have the weights. And from that, we can answer our question. How heavy is this robin? Drum roll, please. Oh, look at that. You're actually doing it. This is exciting. 26.3 grams. 26 grams. The average weight of a robin in the UK, if I failed to mention it already, is 18 grams. I weighed other robins with this bird feeder. They weighed 18 grams. This robin is 60% above the average weight. That is like the difference between me as an adult man and a professional rugby player. This robin is swole. He's huge. Obviously, like any good data-y person, I look at that and I'm like, that's a funny number, but it's wrong. So I check my setup, I recalibrate, I get more readings, I weigh other robins, and it's accurate. Like, this robin weighs 26.3 grams. We observed it repeatedly with multiple setups and multiple calibrations. That's a big robin. And there you go. And whilst I was doing some more research after this project, I came across this slightly more uplifting fact about robins, which is, whilst most robins don't survive their first year, it has a good chance of living like much longer. Some robins can live up to 19 years. Like, I have a sister younger than that. There's a robin out there who's got its life figured out more than her. And I'm very happy to report that this project was happening kind of December of last year, was the last like final sprint on me getting this working. I've since measured a 26-gram robin at the beginning of this year. So who can say? Something about a robin being that heavy, keeping it going for a long time. Who thought? I've talked about a lot of the things I'm not. I'm not necessarily a data scientist. I'm not necessarily a machine learning engineer. In this project, I did enjoy learning about both of those things a lot in order to answer my stupid question, but I am a data engineer. And at this point in the project, I go, oh, I've got all of this fun data that I can do things with. So I built this. This is a little Cloudflare worker pointing at all of the images that are in cloud storage. And this is a dashboard of every bird that visits my bird feeder and all of their weights. Now, all of these weights are wrong because I have lost the war with pigeons. You know, I fought the pigeons and the pigeons won. Sometimes 3 pigeons get on the bird feeder. And they don't make suction cups rated for 3 pigeons that you can get back off a window when you're done. So the weights are junk. I may revisit this and try maybe other types of sensors to try and get some accurate weights. But this has been the super fun part of this project to me. I was in Eastern Europe for work last year. Very short days, very dark, kind of miserable. But I could look at my bird feeder back home, and I could see all of the birds. And it was kind of nice. It sort of cheered me up. It's been a very nice part of this project. Another thing you might notice about this data is there haven't been any birds visiting in a while. And that is because, and here's a little PSA for you, the RSPB actually encourage you to feed seasonally to prevent the spread of avian diseases. So during the summer, there's a higher risk of disease spreading. Birds can be going and foraging very successfully in the summer. They don't need to be fed necessarily. So between May and October, you can refrain from giving them birdseed and instead give them small amounts of other stuff. And that can really help cut down the spread of disease and try and get those robins into the 19-year demographic. So yeah, we have not put any birdseed in our bird feeder in quite some time, so no birds. It's very sad, but we like to be responsible and take good care of our wildlife. So yeah, thank you so much for listening. If you are interested in any of the code or the data or a more in-depth dive into the hardware of this project, everything is over on GitHub. I hope that QR code works. If it doesn't, I will be in the Q&A tent after this talk, so come say hi. And yes, thank you so much for listening.